can't add on the top and bottom. It's just like if you take the fraction 3/4. You can't just add 2 here and add 2 here. That'd become 5/6. That's not the same as 3/4. Right? So you cannot add top and bottom. I can only multiply. So unfortunately for you and every calculus student, you have to actually multiply this by whatever the other one is. A plus h plus 5 on the top and the bottom. And then this one, you have to multiply the top and bottom of that one by what? A plus 5. Yeah, a plus 5. Now notice everything in blue is what I have inserted into the problem, right? Notice I even put like parentheses. I put parentheses around this because I'm going to have to multiply this times this, right? This was up here. I put parentheses around that because I've got to do some crazy distribution here. This times this, I've got to do distribution. I promised ugly algebra. I'm delivering. All right, here we go. I'm going to erase this. I'm tired of looking at that. All right, here we go. Equals limit. Still writing the limit. When I multiply the top left together, these two right here, when I multiply that, I have to go a through to everything, then 5 through to everything, and then I'll be done, right? So I'm going to have a total of 6 terms just from that multiplication, right? It'll be 2a squared plus 2ah minus 3a. And we keep going. Plus 10a plus 10h. I'm going to need more room. All right, what else? Minus 15. And this is all over the this common denominator, right? Yep. Now, for the common denominator, you normally do not have to multiply this out. Just leave it. Man, I didn't realize it was going to be this hard to talk today. Okay, so that's just this part right here, right? Okay, minus, now 1, 2, 3, 4, 5, 6. Another 6 multiplications to do here. So 2a cubed, 2ah plus 2ah, and plus 10a. And then I have, yeah, I don't know what, wait, why did I put cubed? I don't know why I put cubed. I'm glad you caught that. 2a squared, 2ah, 10a, minus 3a, minus 3h, and then minus 15. I'll get the, yeah, it'll change in a second. And then all of this over the common denominator, right? A plus h plus 5, and then a plus 5, and then all of that. You know it's bad when I got to take like 3 steps to draw the denominator, to draw the division bar. All right. Now, the numerators here, they have the same denominator now, right? So I can combine them together, but be careful because this is a minus, right? And that minus is going to change the signs of everything over here. And then we should get lots of stuff to go away. I'm just writing the numerator over here. Minus 2a squared minus 2ah minus 10a plus 3a plus 3h plus 15. Now, some of you may be sitting there saying, is there like a shortcut? Is there like a shorter way of doing this? And I'm going to tell you that there is actually a shorter way of doing this. But be careful what you wish for. Because once you get the shortcuts to doing this, we start to do really complicated functions. So it's kind of like, we will stop doing the limits to do this. We're actually going to have these shortcuts. So the limit's going to go away. But then, like I said, the functions will become much more complicated. So even the shortcut is still hard. Okay, all of this is over h. All right, somebody double check me. Did I get everything okay there? Did I distribute that negative through?
Yeah.
Yep, okay. Now, hopefully everything goes away except stuff that'll have h's. So I see a 2a cubed, or 2a squared is gone. 10a's?
Hey, wouldn't your 15 on top there have been positive and then it would turn into a negative?
This was already negative, and I'm subtracting, so it becomes positive. Yeah, it's going to go away with this 15 right here, minus 15. What else? The plus 3a minus 3a? 2ah's go away? Wow. See, it's not so bad. It just looks ugly initially. I think that's it. Now I have a 10h and a plus 3h, don't I? Which is 13h. So now I have limit as h goes to 0. I have 13h on top, right? Below that, I have the common denominator. And below that, I have h, don't I? And please remember that this division bar right here is the big division bar. So you could look at that h as being h over 1, and then you have like a fraction over a fraction, right? And if you have a fraction over a fraction, can't you just flip this one up and do multiplication of the reciprocal? So that's how we're going to get those h's to cancel. I mean, you could just right now say they cancel, but you better understand that it's because this h is really down here. So I'm going to flip it just to show you. This would come like this. It'd become 1 over h, and that would become multiplication. That would be gone. And then this h and this h are gone, but you still have that 13. And that's what we wanted, right? We wanted the h to disappear. Do we have any questions? I see some looks of disgust. There it is. Now, let h go to 0. That piece right there is going to go to 0. So the only thing left is a 13 on top, and then a plus 5 times a plus 5, which is a plus 5 squared. There it is. This is the slope of the tangent line at any given value a, right? I want to put the function back up here. I like that. All right, I won't. The original function was 2x. What was it? X plus 5. X plus 5. Okay, that was the original function, right? What is the equation of the tangent line? I would like to know, what is the equation of the tangent line at x equals 0? Okay, so quickly, let's grab the point. What is the point that corresponds to x is 0? 0, negative 3/5. So you're getting that by just plugging 0 in here and getting that, right? Now, what is the slope of the tangent line here at x is 0? So now you come over here and you plug in 0 for a. And that gives you 13 over 25. Now can I erase the bottom? Or?
Yes, you may.
Okay. Y'all understand what I just did here? Okay, so now to find the equation of the tangent line, what I'm going to do is just use this formula, right? So it should be y minus what? Negative 3/5. Good. So minus, it's going to be minus and minus equals the slope, 13/25, x minus the x-coordinate, which was 0, right? And this will be y plus 3/5 equals 13/25 x, because when I distribute through, that 0 kills it off. And solving for y, you get y is equal to 13/25 x minus 3/5. So if I go to my computer now, and I ask the computer to graph this, it's going to graph this crazy rational function. And then it's going to graph, I'm going to have it graph that line, and that line should hit the graph at this point, and it should be tangent to the graph. We shall see. So let's change this to 2x minus 3 over x plus 5. So here's the graph of the original function. Right there. Right, that's the graph of the original function. And I'm going to the point 0 3/5, which is the x-coordinate is 0. So it's this point right here. And my line that I graph should run tangent to that, shouldn't it? Like that? And at least I'm feeling good in terms of the fact that my y-intercept is actually negative 3/5, so that's making me feel good. And the slope is positive, so I'm feeling somewhat confident. So it should be 13x over 25. That slope's looking damn good, isn't it? Minus 3/5. There we go. Pretty good. All right, let's talk a little bit. I think I've done a decent number of examples. Of course, you'll need to do your homework to really feel like you're getting this. And then the next section, we're going to do a bunch more. So you'll have plenty of practice with these things. How do y'all feel about it? All right. Okay, so a couple of things. First of all, some notation. Given y is some function of x, then the slope of the tangent line at x equals a is written f prime of a. Did I show you all that notation? I don't think I did. Okay, this is the notation we use. Instead of me writing down like, hey, find the slope of the tangent line at x equals a. Instead of writing all that down, if I just write f with this little mark here, it's like an apostrophe, f something, that apostrophe a, that's telling you find the slope of tangent line at a. Okay, so it's asking you to do that limit that I erased. All right? So the way you say this is f prime of a. That's the way you say that. If you were going to be like verbally saying what you're seeing there, you say f prime of a. So does everyone understand that that is equal to the limit as h goes to 0 of f of a plus h minus f of a all over h. So that's our new notation. Our notation right here. This is known as, okay, this is the way you say it, but this right here is known as the derivative of f at a. So that's a new word for you, the derivative of f at a. So if someone is saying, hey, look, yeah, you've got this function, and you're going to be finding the derivative of the function at a, what that means is you're going to be finding the slope of the tangent line at a. All right? How you feeling? Y'all ready to? I think I might actually blow your minds a little bit here. Let's see if I can. Let's see if I can. This is just because you want to see how awesome math can be. I'll show you how cool this is. All right, so check this out. We're going to go back. I'd say this information right here is you're not going to be tested on in this part, but everything else, like these 3 examples I gave you, those are like fair game for the test, right? And in the homework, you'll have time to practice that. And you've got what, like less than 48 hours, 47 hours? Okay, so check this out. I want you to go back to college algebra. That is a quadratic function. What does the graph of a quadratic function look like? A parabola, right? So this would look like one of 2 things. It would either look like this or it would look like this, wouldn't it? Depending on A, right? A determines that. A determines that. Okay, and in college algebra, one of the points that we were very interested in was that point right there, the vertex. And there's actually a formula that you were given to find that vertex. The vertex formula, is you were told that the vertex was called the point HK. Do y'all remember that? Okay. And then you were told that the h can be found by doing negative b over 2a. Does that look familiar? So that told you that the x-coordinate of that point, so if you were to graph this, the x-coordinate of that point is negative b over 2a. That's what you were told, right? And it didn't matter which of these you were looking at, right? That'd be negative b over 2a. And then what was the k? Well, all you did was just plug that value into the function. So this was the main thing, though. You needed to be able to calculate that first, right? And that was just given to you, right? You just take whatever number's here, and you make it negative, and then you divide by double that number, and you had it, right? And that, when I'm teaching 1414, I give them this formula. I tell them this is a gift from calculus, right? So I'm going to unpack this gift for you. I'm going to show you where it comes from. You ready? Okay, so let's think about this. If I have a parabola, and I would like to know the highest point or the lowest point, in both of these cases, what can you tell me about the slope of the tangent line? If you're at the highest point or the lowest point on either one of those, what is the slope of the tangent line? It's horizontal. What is the slope of a horizontal line? Positive slope, negative slope, 0 slope, right? So doesn't this point correspond to somewhere where the derivative is 0? Isn't it? Isn't that what I'm asking myself? Where is the derivative 0? Because if this is a parabola, I want to know where the slopes of the tangent line 0 on that. Over here it's not, right? The slope is negative, tangent line. But right there it's 0. Right there, 0. You with me? So here's what I'm going to do. I'm going to find the slope of the tangent line. I'm going to calculate f prime of a. Now we have a problem. There's a problem because see this a? It's going to conflict with this a because they don't mean the same thing in this problem. Do you understand that? Because this is just the coefficient. This right here is like the x-coordinate. So what I need to do is use something other than a. So just so there's no confusion, I'm going to use p. All right? All that does is in our formula, it changes to f prime of p equals limit as h goes to 0 of f of p plus h minus f of p all over h. Do y'all see all I've done is replace the a with p so that I don't confuse it with this a? Yes? Okay. Now watch. I'm going to go very fast through this. Okay, here we go. Limit h goes to 0. I'm going to plug p plus h into this, right? Everywhere I see an x. A, p plus h squared plus b, p plus h plus c. Now subtract from that f of p. That means plugging p into this for x, right? So a p squared plus b p plus c. Y'all with me? Okay. I am now going to do more algebra. And I'm going to square that, which is going to be p squared plus 2ph plus h squared. But then I'm going to distribute an a through it. So it's going to be ap squared plus 2aph plus ah squared. So I expanded that and distributed the a plus bp plus bh plus c minus ap squared minus bp minus c. All of this over h. That looks like a disaster, but good things should happen here. Let's see. Gone, 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 gone. C's gone. We've got an h to factor out, so I'm good at this point, right? So now what I'm going to do, limit h goes to 0. Factor out the h. I'm left with 2ap, I've already pulled the h, sorry. 2ap, then what? Plus ah, plus b, all over h. H's cancel. Now let h go to 0. If h goes to 0, this guy goes away, right? And so all I'm left with is 2ap plus b, right? This is the slope of the tangent line. You give me some point p, right? And this formula will generate the slope of the tangent line. I would love to know when this is 0, wouldn't I? So why don't I set this equal to 0? So what happens if I set that equal to 0 and solve for p, because p is where I need to be, right? What happens? What happens? Negative b, so I get 2ap equals negative b, and now divide by 2a, and you get p is equal to negative b over 2a. So for a quadratic function, if you want to know where the slope of the tangent line is 0 at, which would correspond to the vertex, your x-coordinate needs to be negative b over 2a. Make sense? Pretty awesome. And the reason I showed you this is because in college algebra, when we have a quadratic, we can find the highest and lowest points, can't we? That we can do. What happens when it becomes a cubic function? Or fourth degree, right? Can we find the highest and lowest points? Well, no, we can't. There's no formula anyone ever gave us, right? But what we can do is what? Take the derivative and set it equal to 0. And then we can find out where the highest and lowest points are. And that's part of what we're going to be doing. Or, we're going to have some function. It's going to be some crazy function. We're not even going to know what it looks like. And we're going to be trying to figure out where these, what we call local maximums and minimums occur. And what we notice is that at each one of those points, our derivatives are 0. So we find the derivative, and we set it to 0. This right here was nice. It was a little linear equation, easy to solve, but this may turn out to be a quadratic equation, a radical equation, a rational equation, all sorts of messy stuff that can happen here. So that's where we're headed. All right? I'm losing my ability to talk here. So let's talk about test, yes?
Yeah.
Grab a piece of paper. Even though this will all be recorded, I still think you should jot some things down. Now, first, a disclaimer. I still have not written the test. So I'm not saying that what I'm about to say is exactly a carbon copy of what this test is going to be. But I'm going to run through the most recent Calculus 1 test that I've given, and the topics on it, I think, are very much in line with what you should expect. But if there's something I don't mention, that's either on the homework or something we covered in class, that's fair game, all right? So let me bring up that old test. Okay, the old test that I gave was 16 questions and a bonus, but that test that I gave got all the way up through 2.2. Yours is only going through 2.1. So I'm guessing yours will probably be 15 questions or so, all right? The first question that I asked on this test was I gave them a graph. So I drew a function, and I asked for a bunch of limits. Limits from the left, limits from the right, functions, values at points. So it was kind of like that first idea of, the idea of the limit being calculus, looking through the calculus goggles, as opposed to the college algebra goggles, right? We talked about that. So I give you a graph, you come up with limits. I think you had a quiz like that, didn't you?
Yeah.
Okay. So I would expect, definitely, you're going to have something like that, all right? The second question was different. What I did is I gave them a bunch of conditions. Like I said, okay, you need to draw me a function that is, right continuous here. The limit from, the left as you approach 2 is infinity, but the limit as you approach 2 from the right is 4, and f of 2 is undefined. So I give all this list. There's the conditions. I gave conditions A, B, C, D, E, F, G, H. So all those conditions, and then the student has to draw the function. So when I did one like that in class, I believe, everyone's picture is going to look a little different, but we should all have something. These properties should all be clear in your function. And at the end of the day, your drawing should look like a function, like it should pass the vertical line test. It can't be like weird wrapping around itself. So that's the second one. And then from that point, I started asking about limits. So we've got a limit here, direct substitution, right? Where you just plug in and see what happens. And remember that you always want to do direct substitution first. Because what if you get something like, 3 over 5? You're done, right? Okay, so always do your direct substitution. Make sure you have a problem. And then there's another problem. There's a bunch of limits now. So number 3 was a limit. Number 4 was a limit. On the fourth one, they had some 0 over 0. And they had to do some basic factoring. Basic factoring meaning like quadratic stuff, factoring trinomials, and it all works out. Then as it progressed through, another limit, 0 over 0 again, but the factoring started to get a little more complicated. All right. Number 6, another limit, getting 0 over 0. This one happened to have a conjugate in it. Okay, so they had to do a conjugate in order to get this limit to work. Then there was a limit where they had to use that sign of junk over junk idea. That one students always have trouble with. That's the one where you have to rip the expression apart, find the trouble spot, introduce something like, introduce 2 theta over 2 theta or something like that, and then start sliding things around. Did someone in here email me or text me about the sliding? Was that you? Does that make sense now? Yeah. Okay. All right, so when you slide things around, and get things to go away. So one of those is on here. The next one was a problem from the section on continuity. And in the homework, there's a problem where it's a piecewise function, and they give you 2 pieces, and they have one variable in there. I think they use C, and then you have to figure out what the value of C is that makes the function continuous. And I believe I just gave them that problem right out of the book. Now, I'm not saying that that's what will happen, but that gives you an idea. From that section, continuity, that's the type of question I ask. Piecewise function, there's a variable. You have to find the variable that makes these 2 pieces come together. I believe in our class, I did the one where it had 3 pieces. And we had to solve a system of equations. On the test, I didn't even do that. I did one step lower than that, which is there's only really going to come one equation. You just solve for C and you're done. But I would be prepared for both.
Well, right? The bonus question, that'll be the 2 variables, right?
We'll see. I don't remember what the... Okay, so then more limits, number 9. And for this one, I've got some left and right hand limits where you're getting things like a fixed number over 0. So what happens when you get like a fixed number over 0? What?
Infinity, negative.
You can have infinity, negative infinity, or doesn't exist. So you have to determine, and this is where you have to like kind of draw a little number line, be like, hey, I'm going to come in from this side, and that means the bottom is going to 0, but it's positive, but the numerator is negative, and so the ratio is negative. So this is the one was, there's not a lot of work to do, but you still have to try and understand what's happening. So you have one of those. The next one was a limit. This time the limit was going to infinity. So x was approaching infinity. And do you remember the technique when you have x going to infinity and you're getting infinity over infinity? Try and come through, you multiply top and bottom by something that'll kill off the highest power of the denominator. That's what this one was. The one after that was the same idea, infinity over infinity, but the bottom had a square root in it. So it wasn't as simple as just identifying the highest power. You had to remember that when you force something into a root, it gets squared on its way in. And so again, I did one of those in class. It's on the test. And then number 12 was infinity minus infinity. And when you have infinity minus infinity, that's when you factor something out and make it multiplication instead of subtraction. Again, I did one of those in class, and they're on your homework too. Number 13, find the equation of the tangent line. I gave them a function, I gave them the point. So that's like the first problem I did today. I gave you the point, asked for the equation of the tangent line. Number 14, same thing. Gave them a function, gave them a point. And that's number 15, ask them for f prime of a. Gave them a function, asked for f prime of a. And that's it. I can't, the rest of it we haven't talked about. The bonus, well, that bonus is actually way fair game. Does that give you a good idea of the type of test? I think the biggest issue you're going to have is time. You know, you have an hour, 40 minutes. So, all right, can you turn the light, all the lights on, and then on, so just turn them all up, and then on, other way, on. No, on. And then on that black panel, can you, bottom left corner, it says off. Hit that. Yep. There you go. Okay, so I know you want to go and, you know, but I think there's one more problem I think is worth you seeing. Okay? Just to see the algebra involved. Okay, what if you had something like this? Or I'll give you another function that would be similar to this. Okay, both of those, but let's do the one on top. If you're asked for f prime of a, you're going to do the limit as h goes to 0, oops, of f of a plus h. Minus f of a over h. I just wouldn't want to hit you with something like this on the test and y'all be all upset with me that you never saw anything like this. So here's the function I'm doing. I'm doing f of a plus h, so I'm replacing the x with a plus h. And then I'm doing minus f of a, so I'm replacing the x with a. So everything, does that look like what it should look like to you? Yep? Okay. Now, what you might be thinking right now is conjugate, because you see the roots, right? The problem with that is it won't work, okay? You actually have to get these together as a common denominator first, with a common denominator first. So that means you have to introduce on the top and bottom here root a plus h plus 1, root a plus h plus 1. And over here, root a plus 1 and root a plus 1. Do y'all see what I'm doing? I'm getting a common denominator. Limit h goes to 0. I have root a plus 1 minus root a plus h plus 1 all over root a plus 1 times root a plus h plus 1, all of that over h. Now I'll explain what the heck just happened there. Just make sure you're with me here. All right, so when I put these together, I do root a plus 1 times 1. Then I'm going to subtract 1 times this one, which gives me this top piece. And then my common denominator is here. And then all of it over h. So does that line make sense? OK, so you're OK with why I'm introducing these, right? So when I multiply these two together, I get just this times 1, right? Which is just this over this. And then here, 1 times that is just that over this. They have the same denominators now, don't they? So I'm just going to put this numerator minus this numerator, that's here, over that common denominator, then all that over h. OK, at this point, now you can come in with the conjugate. Now you can. So what I would recommend you do is this. Right here, see you still have a fraction, don't you? I would bring your conjugate in like this. Root a plus 1 plus root a plus h plus 1. And then just put the other piece right underneath it. Root a plus 1 plus root a plus h plus 1. Like that. And let's see what I did there? I'm doing the conjugate of this right there. Should I continue?
Continue.
OK. So what happens up top when I do this?
Go away.
Yeah, you're only going to do the first and last terms that are going to matter. So I should have limit h goes to 0. What, a plus 1? A plus 1 from here. And then because this is minus and plus, it's going to be minus this stuff. So how about minus a minus h minus 1? I already distributed the negative through. That is sitting over this disgusting looking root a plus 1 times root a plus h plus 1 times root a plus 1 plus root a plus h plus 1. And all of that is on top of h. So notice that on this part right here, this and this, I didn't try and put these together. I just left this and this. Because really what I want is for an h up here to cancel with an h down here. And do I get cancellation up there? Oh, I do. A's gone, 1's gone. And I have a negative h up top still, right? The algebra of this one is really messy. So I have limit h goes to 0, negative h over, oh, well, you know what? Do I have to do negative h? Can I cancel it now? Yeah. OK, I'm going to cancel it now. This will cancel out. This will cancel. Don't forget, you'll have a negative 1 right here, right? Right? So I have negative 1. We're almost there. Negative 1 over, OK, I have root a plus 1 times root a plus h plus 1. All that times root a plus 1 plus root a plus h plus 1. That. And now at this point, we can let h go to 0. And when h goes to 0, this piece is going to vanish out to 0. That piece is going to vanish. So this becomes root a plus 1 times what? Root a plus 1. So the two roots multiply together, just become a plus 1. So this is becoming negative 1 over, I'm taking the limit right now, so I just get a plus 1 out front. That's these two together. And then this right here becomes root a plus 1 plus root a plus 1, which is 2 of them. So I'm going to put the 2 out here and put root a plus 1 right there. And that's the derivative. That is the slope of the tangent line at a. All right. Well, it's 10:40. I was not able to grade your quizzes. Friday I took the day off because I wasn't feeling well. So I was going to grade them, but I had them on my desk. So all weekend I didn't have access to them. So I got here this morning. I didn't have time to grade them. So do you feel like you need them to study, or are y'all okay? You all right? Okay, as far as signing in, we just won't sign in today. Yeah, that way you can go. It's 10:40 already. We'll see you on Wednesday for your test. Make sure you sleep and eat before you get here.
So, sir, are you going to give us, like, for example, F3 plus H minus F3?
Am I going to give you the formula?